Today's presentation is titled Ultraviolet Radiation, Radiation of Greatest Threat but Least Concern by Dr. Kerryn King. Kerryn is a scientist at ARPANSA with over 10 years experience in ultraviolet radiation, being UVR, in particular in measurement and assessment and occupational safety. Kerryn has wide-ranging knowledge of radiation protection and has played a leading role in advancing radiation protection nationally. Kerryn is a member of ARPANSA's UVR team that performs measurements on the effectiveness of a range of commercial products that provide protection from solar UVR. Kerryn provides UVR protection advice and undertakes risk assessments of artificial and solar UVR in the public and occupational settings. Kerryn presents ARPANSA on 3 separate sun protection standards Australia committees for eye and face protection, including sunglasses, sun protective clothing, and sunscreens. In these committees, Kerryn has been instrumental in promoting best practice in UVR protection and prevention. And with that, over to you, Kerryn.
Thank you. Ultraviolet radiation, the radiation of greatest threat but least concern. So today I'll be talking about briefly what ARPANSA is, ultraviolet radiation, the greatest threat and least concern discussion, ultraviolet radiation regulation and guidance, ultraviolet radiation protection, briefly touch on lasers, and then the summary. So ARPANSA, who is ARPANSA and what does ARPANSA do? ARPANSA stands for Australian Radiation Protection and Nuclear Safety Agency. We are the Australia's government's primary authority on radiation protection and nuclear safety, and we provide protection, advice, and health to the health and safety of people and the environment from the harmful effects of radiation through the research, advice, and services we provide. So, ultraviolet radiation. What is ultraviolet radiation? The sources, solar UVR levels, why the concern, health effects, protection, reporting, regulation and guidance, and what you can do will be touched on. Ultraviolet radiation is the optical radiation that sits on the electromagnetic radiation spectrum between visible light and X-rays. It consists of UVA, UVB, and UVC, and all UV radiation is considered carcinogenic by the International Agency for Research on Cancer. Where do we find sources of ultraviolet radiation? The biggest one's the sun, but it also can be occurring with welding, black lights, germicidal lamps, curing lamps, solaria, lasers, and other various light sources. And examples of these are in the pictures here. But not all UVR is equal. Every source has a different spectra. An example is shown to the left. This is a transilluminator. It has both a UVA transilluminator and a UVC transilluminator and a UVA transilluminator. So the UVC spectrum from the transilluminator is in this red line on this axis. And then the UVA transilluminator spectra is in the black. And then another spectra that's shown is a UVB phototherapy lamp, and it has a nice sharp peak in the UVB spectra. But the biggest source is the sun. The sun emits all 3 types of UVR. However, the UVC is totally absorbed by the atmosphere. UVB is absorbed up to 90% by the atmosphere, and only 5 to 10% reaches the surface. And the UVA, very little is absorbed by the atmosphere, and 90 to 95% reaches the surface. The things to remember with the sun. The solar ultraviolet radiation consists of both direct, scattered, and reflected radiation. It penetrates clouds and water, reflects off surfaces, and in shade, you can still receive up to 50% of your ultraviolet radiation. The UVR peaks between 10 AM and 3 PM, and Australia has extreme levels of solar UVR. We often have UV index levels that are 11 or more, and all UVR exposures add up to a lifetime of skin damage. Therefore, we need to cover up. This is an example of the solar UVR levels versus latitude. The closer you get to the equator, the higher the solar UVR levels occur. but the Northern Hemisphere has lower UVR levels at the same latitude compared to the Southern Hemisphere. So Australia are these red squares, and equivalent areas from, say, Japan in the Northern Hemisphere and the USA are lower than what would be received in Australia. The same thing happens with Australia. Closer to the equator in Darwin, we reach much higher levels and total accumulative doses, otherwise known as standard erythemal doses. So the yellow is the UV index maximums that have been recorded in each location, and the purple are the total annual solar erythemal doses that are received for that location for the entire year. So Darwin has much higher levels compared to Hobart. And you'll notice Perth, which tends to have a lot more clear sky days with less cloud cover, has a higher UV index and higher total doses compared to Adelaide. So why UVR? As I said, Australia has extreme levels of solar UVR, particularly in summer. The UVA, UVB and UVC are all considered carcinogenic and are considered a class 1 carcinogen. There are acute health effects, such as the sunburn of the skin and eyes, but also chronic health effects, which include premature skin aging, cataracts and skin cancers. Australia has the highest incidence of skin cancer in the world. 2 out of 3 Australians will be diagnosed with skin cancer by the age of 70. And over 750,000 Australians will be diagnosed each year with skin cancer, and over 2,200 die. Melanoma is the most common cancer for people aged 15 to 29 years old. So apologies if these images are disturbing, but they are a non-melanoma skin cancer, a melanoma, and a cataract. And up to 80% of all new cancers diagnosed every year are skin cancers. Approximately 13,300 are melanomas, and in excess of 500,000 non-melanoma skin cancers are diagnosed each year. Occupationally, about 200 melanomas and 34,000 non-melanoma skin cancers are diagnosed each year. In 2004, there were 73,000 people with cataracts. Cataracts are another cause of UV damage, and it can result in blindness. UVR also contributes to macular degeneration. So there are other health effects, things like skin erythema, which is reddening of the skin, tanning, sunburn, skin wrinkling, premature aging, immunosuppression, photokeratitis, which is a sunburn of the cornea, snow blindness and welder's flash are also other names for photokeratitis, pterygium and penicilla. But unfortunately, in Australia, it seems to be the radiation of least concern, as can be demonstrated in this photo. Quite frequently, we see lots of people out without any form of sun protection whatsoever getting sun damage. Radiation has both good and bad health effects. Too little and vitamin D deficiency can occur, and that can be in its severest form, rickets, and too much, and you end up with skin cancer and cataracts. So quite frequently, people who are workers that are indoors all day, every day, tend to get not enough vitamin D. So their doctors tell them to go out and get sun to get some vitamin D. So a lot of people are getting mixed messages with whether to use sun protection or to go and get some sun to get the vitamin D. Unfortunately, too much UV and you can end up with sufficient energy to cause photochemical damage to your cellular DNA. Optimal exposure relies on getting the balance right. Unfortunately, UVR is also invisible and it cannot be felt. And overexposures can take up to 24 hours to show. Outdoor exposures, we have had in the past people wearing very little clothing when they're doing outdoor work, such as these images of the worker on the roof or the lifesavers wearing very little in the way of sun protection. And when we did measurements, 9 out of 10 workers exceeded the exposure limits, 50% exceeded the exposure by up to 4 times, 75% of workers reported sunburns, and they were getting ambient levels of approximately 60 standard erythemal doses every day. What is interesting with this, when we did another study, was the roofers, the ambient levels were only reaching 16 CEDs. However, the workers were getting exposures in excess of 24 CEDs. And that is because of the roofing iron they were working with, and that was causing both the actual ambient exposures as well as the reflected exposures from the roofing iron that they were working with. So you have to be careful, not just of the ambient, but also the reflections that you might be receiving from other sources. So ARPANSA and the International Commission on Non-Ionising Radiation Protection have both issued guidance for protecting workers from the ultraviolet radiation. But ARPANSA is the only regulator of ultraviolet radiation, and all of the states don't regulate ultraviolet radiation except for solaria and lasers. So therefore, most people are only protected by the harmonisation work health and safety laws. And so the radiation regulators don't tend to set any sort of guidance, and it's left to the work health and safety regulators to do the regulation. And so therefore, all of the information that ARPANSA provides is considered guidance and not a regulation. So the Safe Work Australia has released a guide on exposure to solar ultraviolet radiation. So these are the 2 guidance documents that are available for Australia for occupational exposures. And the ARPANSA one is Radiation Protection Standard for Occupational Exposure to Ultraviolet Radiation, also known as RPS 12, that is available on our website. And it provides information on the occupational limits and the controls that should be used for protecting the skin and eyes from artificial sources. And it also provides some guidance for solar ultraviolet radiation. Solar ultraviolet radiation is guidance only because the limits are usually exceeded in a few minutes with the sun, as it's an uncontrolled source. So Radiation Protection Series 12 has threshold exposure limits. It has a risk management process, and it also recommends having a workplace policy, such as a radiation protection plan. There are also standards, such as the Laboratory Standard for Ultraviolet Radiation, Safety in Laboratories, Australian and New Zealand Standard 2243.5, Safety in Laboratories Part 5, NIR, Electromagnetic, Sound and Ultrasound. This actually is open for public comment until the 13th of September this year, as it's just recently been reviewed. And it provides the general principles of protection, including hazard identification, risk assessment, controls, training, signage, incident and accident reporting. And for the UVR, hazards, permissible exposure times, and the PPE recommended. Various sources of laboratory ultraviolet radiation are your biohazard cabinets and your laminar flow cabinets, your water and air sterilizers, your spectrophotometers, and your transilluminators. Some of these are considered controlled apparatus by ARPANSA, but as I said, state regulators, they don't have any controls on these sorts of instruments. The Australian standards for safety signs in the occupational environment specify this image here for the non-ionising, including ultraviolet radiation. And they also are filters for eye protectors, part 2 for ultraviolet radiation that recommend various eye protection. That is also about to be reviewed, so that will be changing shortly. The World Health Organization also has a global solar awareness. Okay, so the World Health Organization does specify the UV index, and it has the ranges. So 2 to 5 is basically you can stay safely outdoors, and it uses the color code of green. 3 to 5 is moderate, and that's when you start to use the slip, slop, slap, seek and slide. And 6 to 7 is high, that's an orange color scale, and it also recommends to stay indoors between 10 and 3. 8 to 10, stay indoors as much as possible and use all precautions if you're outside, and that's in red. And then the purple for the ultraviolet radiation color for anything 11 and above. And basically that's staying inside. In Australia, the northern parts of Australia are generally staying around 8 to 11 all year round. And in the southern hemisphere, in the southern parts of Australia, we end up with winter being low, usually below 3 for 1 to 2 months of the year. And then for the rest of the year, it is above that UV index of 3 all year round for the rest of the year. Other places that provide regulations and guidance, as I said, the regulators are the ones that provide the work health and safety regulators, not the radiation regulators that do this regulation of work UVR. But the Cancer Council also has a lot of resources and guidance on skin cancer and outdoor work. This is a demonstration of Melbourne over the year, and you'll notice that regardless between Brisbane, this is showing that regardless, you're in a high region of concern all year round, and there's only between 10 and 3. The rest of the time you don't need to. Occupational people are recommended to use sun protection all year round, regardless of what the UV index is doing. There's 5 ways of personal sun protection. We've all heard them. Sid the Seagull from the 80s has mentioned it. Slip, slop, slap. They've added seek, shade and slide on sunglasses. So slip on sun protective clothing, slop on sunscreen, slap on a hat, seek shade and slide on sunglasses. There are Australian standards for the 5 sun protection methods. But there's actually only 4 Australian standards, and they are the sunscreen standard, eye and face protection for sunglasses and fashion spectacles, knitted and woven shade fabrics for the shade, and the sun protective clothing for the hats and clothing. Australian standards set out the requirements for the testing of the effectiveness of a product's sun protection and how to rate the effectiveness. So an SPF for sunscreen, UPF for clothing and hats, UVE for shade fabric. And the sunglasses use a category 0 to 4, with 2 and 3 being good UV protection and 4 being a high protection. Sunscreen products, they're tested on humans. So ARPANSA does not do this sort of testing because it is an ethical concern exposing people to a known carcinogen. We are investigating in vitro method though. Sunglasses, we've Sunglasses are a mandatory test standard, and Australia tests to 400, not 380 nanometers, and there are required wording and pictograms that should be attached to sunglasses. Other alternatives are the occupational health, occupational sunglasses under the 1337, and you want the outdoor rated sunglasses. There are required wordings for the sunglasses and labelling that must accompany any pair of sunglasses sold. And as you'll see here, you've got the 0 and 1 are only providing some UV protection. The 2 and 3 are the general purpose sunglasses that provide good UV protection. And then the 4 is the very dark special purpose sunglasses used for things like highly reflective surfaces such as snowfields on the sea, or high in the mountains or in deserts where you get high reflections also occurring. The sun protective clothing standard was revised in 2020. It has a minimum level of body coverage to claim a UPF rating. And the rating system is a UPF 15, which gives approximately 2 hours of sun protection. A UPF of 30 gives approximately 4 hours of sun protection, and a UPF of 50 or 50 plus, which gives all day sun protection in an Australian summer. There are minimum skin coverage requirements. For hats, there's a 7.5 centimetre brim width for most hats, and the gloves must cover the entire back of the hand to be able to claim a protection. Baseball caps are not permitted, and neither are sun visors to claim a UPF rating, and neither are things like bikinis and those sorts of things. So a good example is this broad brim hat or the bucket hat and a Legionnaire hat are all hats that are considered to provide good protection. The body coverage is basically from the neck down to the hip line for the upper body, with arms reaching 3/4 of the way down to the elbow. And for the lower body coverage, it's to the waistline and down halfway down the thigh to the knee from the inside of the crotch. Shade fabrics now have a human protection, which is called an ultraviolet effectiveness rating. And with the addition of the shade fabrics being able to do a human protection rating, the clothing standard now no longer permits items not in contact with the skin to claim a protection of a UPF rating, and all shade items now must be tested to this knitted and woven shade fabric standard. So it includes knitted and woven. So things like canvas are an example of a woven shade fabric. A knitted shade fabric is your sunshade sails, things like that. It has a human sun protection rating, and there are also other requirements such as the strength, so that it can withstand things like a heavy rainstorm, hail, or things of that nature. So it has a rating of 80 to 90% for effective, 91 to 94 for very effective, and 95 plus for most effective. Now, this is an example of an Australian standard where the protections are not as good as they could be, because the UPF is equivalent to minimum UPF rating is UPF of 15, and that's equivalent to a 93% protection. ARPANSA tests to the Australian standards for sunglasses, sun protective clothing and hats, and shade fabric. We also test automotive tint films and also building products. So we provide sun protection testing swing tags, UVR measurement and dosimetry, research, education and guidance. ARPANSA's public information is mostly to do with our solar UVR detection network, where we provide real-time UV index and also a UV dose data. We also provide a UVR education poster for anyone that requests it. And with UV, there is another thing that we should mention. All of the UVR that I've mentioned so far is to do with incoherent optical radiation. There is the lasers, which are culminated or divergent beams. And as you can see here, there are 6 laser types that emit in the UV up to the 400 nanometer wavelengths. All of these are not visible to the human eye, and so are a risk to the users and those nearby because they can be reflected off items and into the space of other people. With lasers, they tend to be very tight in their spectra, usually 1 or 2 nanometers at most. And we can measure those with various measurement devices, but laser accidents occur all the time. And the most common are eye injuries. And they typically occur with incorrect eyewear, not wearing eyewear at all, and during the alignment procedures. So in summary, as radiation protection specialists, you now know the risks. You also know the protections that should be used. So please ensure that protections are used in your workplace, especially for anyone working outdoors. And remember, whether you, your family, or your work colleagues are at work, rest, or play, the UV exposures all add up. So please slip, slop, slap, seek, and slide. Thank you.